We are discussing the chapter 11, 3D geometry or three-dimensional geometry. So let us start. First of all, we'll talk about the angle between two lines. The angle between two lines, if these are our two lines, say this is L1 and this is L2, this is the angle which we are talking about. These are the lines and they are passing through, just assume that they are passing through the origin, and they have direction ratios as A1, B1, C1 and A2, B2, C2. And let this P be a point on L1 and Q be the point on L2. Just consider the directed lines, this OP and OQ, and they are making theta between them, acute angle. So we know that what is the cos theta between them. This is nothing but A1 A2 plus B1 B2 plus C1 C2 by under root A1 square plus B1 square plus C1 square under root A2 square plus B2 square plus C2 square. And the angle between the lines in terms of sin theta, we know that sin square theta plus cos square theta is 1. So sin theta will be under root 1 minus cos square theta. What it will be, just place cos here and just try to solve it. This will be the equation. So if this L1 and L2, they are not passing through origin. So here we can take some L1 dash and L2 dash, which may be parallel to L1 and L2, which are passing through origin. This we can do. So instead of the direction ratios in the previous discussion, if this L1 and L2 are there, instead of using the direction ratios, if we have direction cosines like the L1 M1 N1, L2 M2 N2, then what will be cos theta? This will be nothing but L1 L2, because we don't need that under root A1 square, B1 square, C1 square here, because this is directly the cosine direction cosines being provided to us. So L1 L2 M1 M2 and N1 N2, we know that this square plus this square and this square, they are 1. If we add the square of the direction cosines, they will always be equal to 1. And similarly, placing it into under root 1 minus cos square theta, sin theta will be this one. So here we observe that two lines, if they have directional ratios these, and if they are perpendicular, that means the angle is what? 90 degree, right? The angle is 20 degree. So A1, the cos theta will be 90. So cos 90 will be 0. So the numerator will be 0. While in the case where theta equal to 0, cos 0 is 1. So the ratio will be A1 by A2, B1 by B2, C1 by C2 will be in some ratio. So let us find the angle between these two lines now with the equation we have. We have say a line R is equal to A1 plus lambda B1. R is A2 plus mu B2. These are two lines, one line, two line. Now these are in the vector form. So what will be cos theta? We have already seen this will be B1 B2, this dot product by the magnitude of B1 B2. And in Cartesian form, the line of equation is this. We know that the Cartesian form, a line equation is like this. So when we find out the cos theta, it will be again A1 A2 B1 B2 and C1 C2 divided by the, of course, the square of the coefficients of ijk. Let us understand it more by some examples. If R is this is A1 plus lambda B1, this is A2 plus mu B2. We want to find out the angle, so we can just take this B1 as this one, B2 is this one, and theta is simply cos theta is B1 dot B2 divided by under root the B1 B2 magnitude, that is 1 square plus 2 square plus 2 square under root, and 3 square plus 2 square plus 6 square under root. Just place it here. You get 19 by 21. This will be theta will be cos inverse 19 by 21. If you have to find the angle between the pair of line when this Cartesian form is given, then here we'll take this 3, 5, 4 and 1, 1, 2. These are the direction ratios. These are our direction ratios. We can directly use A1, A2, B1, B2, C1, C2. This is the sum of square of this. This is the sum of square of this, and just find out this will be cos inverse 8 root 3 by 15. Now the shortest distance between two lines. See, if we have these two lines, if two lines they lie in a space, any space, if they intersect at some point, then we say the distance between them is 0. Shortest distance is 0. But if two lines they are parallel, the shortest distance is what? The perpendicular distance between them. That is the length of the perpendicular drawn from one point of this line to the another point. But in space, there may be line which may neither be this way or nor be this way, may neither intersecting nor parallel. So these pair of lines, if they are not in single plane or not in one plane, they are called non-coplanar, and these lines are known as skew lines. Right? Just consider this room. Say it has some size 132, and we have this size XYZ. So just join these two points. Just join these 2 points. They are neither parallel. They will never intersect. They will never intersect. This is what I wanted to say. So these are skew lines. So how to find the distance between two skew lines now? We have lines in different planes. They are neither intersecting nor parallel. So in order to determine the shortest distance between two skew lines, if we say L1 is this, L2 is this, L1 can be easily represented by A1 plus lambda B1 or by A2 lambda mu B2. Now take any point, say S, on this L1. Let A has a position vector A1 and this T, okay, T on L2, say position vector A2. So now the distance, the magnitude of the shortest distance between the vector will be always equal to the projection of this ST along the direction of the line of shortest distance. So we just have to take the projection of this line on that shortest distance. So if this PQ is the shortest distance between say L1 and L2, then because it is perpendicular to, because two lines perpendicular distance is the shortest distance, because now this line is perpendicular to B1 and also perpendicular to B2. So we have a unit vector n cap along some PQ, which will be what? Which is perpendicular to B1 cross B2, which will be perpendicular to B. This is B1, this is B2, perpendicular to both of them. So B1 cross B2 by B1 cross B2, this modulus, or you can say the magnitude. So what will be PQ? It will be simply D distance into n cap, D into n cap, right? PQ will be nothing but this is the n cap, that is the direction of that line. Now D is the magnitude of the shortest distance. So getting the vector, that is D into n cap. So let us say that there is a theta angle between ST and PQ. This ST and PQ, there is angle, some angle theta. So how to find it? PQ will be simply ST cos theta y, because as I just said that the shortest distance is nothing but, say I have two lines. If this I am taking, I want to find out, I have these 2 points, I have to find the shortest distance. So this is the shortest distance. So if I have line, so this shortest distance is nothing but the projection of this line on this. This is what we are finding. PQ is equal to ST cos theta. So cos theta will be what? PQ dot ST by magnitude of PQ ST. But we have just known that this PQ is D into n cap. We just found out. We can again write it here. But ST is what? We took it as A1, we took it as A2. So ST will be A2 minus A1. Just place it here, A2 minus A1. Right? So what we got? What we got? This is nothing but this was B1 cross B2. This is like this. This was B1 cross B2 by B1 cross B2 mod. And this is nothing but ST. Let us keep it here. So the required shortest distance, which is the D, is nothing but PQ, which is actually ST cos theta. Now multiply this by ST, you get this one. So this is the D, B1 cross B2 dot A2 minus A1 by B1 cross B2 magnitude. So in the Cartesian form, if L1 and L2 are line equation of this form, the shortest distance will be x2 minus x1, y2 minus y1, z2 minus z1, then a1 b1 c1, a2 b2 c2, this in the matrix form. That is, you have to find out the determinant of this and divided by the b1 c2. If you take a1, this will be b1 c2 minus b2 c1 whole square, and similarly for others also. Now how to find the distance between parallel lines? Now it becomes quite easy now. Why? Because now this b becomes equal, because they are parallel. So if two lines L1 and L2, they are parallel, they are coplanar. They are coplanar. So they will have b as similar. So this a1 and a2 are the position vector of point S on L1 and point T on L2, on this T on L2 in this figure. So this L1 and L2, now they are coplanar if the foot of the perpendicular from T on the line, this one L1, is P. So distance between L1 and L2 is what? This will be simply again the projection of ST on this TP. So if theta is this angle between ST and B, that is, what will be the ST and B? Just B and ST, just take the cross product, which this will be B into ST sine theta n cap. So let us find out the n cap, right? This n cap is the perpendicular line, is a unit vector which is perpendicular to both L1 and L2. And what is ST here? What is ST here? ST is nothing but A2 minus A1. This is A2 minus A1. So now just place it here, ST. B into ST is B PT. And we know that PT is nothing but PT sine theta, ST sine theta. See, what is this TP? TP is nothing but this sine theta. Okay, sine theta is perpendicular by hypotenuse. This is perpendicular and this is hypotenuse. So just place it, you will get the value of PT also ST sine theta. You can just directly place there. And this n cap, of course, the magnitude of n cap, if you take the magnitude of both the sides, you get this one, n cap as 1. So what you get? PT, which is the distance, which is actual distance. Divide this B here. So this will be B1 cross A2 minus A1 by mod of B. Now let us find out the shortest distance between these two lines, whose equation are like this. So they are non-coplanar skew lines. This is A1, this is B1, this is A2, this is B2. And we know the formula directly. So just equate them with R equal to A1 plus lambda B1. And this is R A2 plus mu B2. A1 is this, B1 is this, A2 is this, B2 is this. Find out A2 minus A1, that is I minus K will come. B1 cross B2, just multiply or take the cross product. And then the cross product will be found out by finding this IJK in the, this is the actually determinant, IJK and these values of IJK. And then B1 cross B2 magnitude. So find out the magnitude of this. 3 square plus 1 square plus 7 square. This is the magnitude of this. Just place in this equation and you get, or this result, you get the final 10 by root 59. Now find the distance between the lines L1 and L2, which is given by this. See, here this B1 and B2, they are equal. That is, these lines are coplanar. So we'll use this formula, B cross A2 minus A1 by the magnitude of B. So A1 here is this, A2 is this, and these are B. So just place it here. You can easily find out this B1, A2 minus A1 first you have to find out. 3 minus 1, 3 minus 2, and minus 5 minus 4, that will come here. And this is 2, 3, 6. This is of course, the B is this, and A2 minus A1 will come here. Just find it out. I hope that you'll be able to do. So this is one more installment of 3D geometry class 12th. Thank you so much. Take care of yourself.